Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today we are going to discuss about how to construct non-deterministic finite automata very easily. So that is what the topic today. So please quickly join and simply mark your presence. You can just say hi or hello. Okay. I hope I am audible and visible to every one of you. Am I audible and am I visible? Just confirm me once. So I once again welcome you all to my session. So that is on summer crash for theory of computation and how to construct the non-deterministic finite automata in today's session. Okay, very easily. So please do share the class information with your friends and also please do like the session. And before I begin the session, let me introduce myself. Myself, Murali Krishna Bokkasamudram. I am having 21 plus years of teaching experience and I am having ISRO certification and also topper of NPTEL course in theory of computation and mentored more than 50,000 students across the country in different core areas of computer science. Those are theory of computation, operating systems, computer organization, computer networks, digital logic, and ICT, information and communication technology. So these are the areas of my expertise. And before I begin the session, please do subscribe the channel if you have not yet done the subscription, and also please do like the session. Okay, and just let me know whether my audio, video, everything is clear. You can just say hi or hello. Is my voice audible? Can you confirm me once? Some of you, please. Okay, fine. Anyway, so there is one Gate Rankers Monsoon series. It's a free course on the YouTube. You can just subscribe right now. The most important topics of electrical, electronics, and computer science. It is from 10th July. You can subscribe right now for all this. Okay, and I hope every one of you are attending the classes for the last 4 days. I've been taking on the theory of computation. Okay, and it will continue up to 8th of this month. Okay, and please do subscribe the channel and please press on the bell button for getting notifications. Okay. And now coming to there is one scholarship test planned on 9th July at 9 a.m. You can register right now for it for getting 90% off on the course fees for the GATE, and it is a national level scholarship test for the GATE exam. You can right now take a step towards success in the GATE. Okay, so this is on 9th July at 9 a.m. So all of you please try to make use of this opportunity and please use this use your skills. If you get a good marks in the national level scholarship test, there is a chance you may get up to 90% off. Okay, so all of you please make use of this. And now let us see different examples regarding how to construct NFA very easily. So before I begin, so I wanted to give you what is NFA. So in NFA, we can have multiple states as the reaching states. So delta is from q cross sigma to 2 power q. So what do you mean by 2 power q? It is a power set. So that means a state and input combinations can give 0 or more states. So let us suppose if q is equal to q0 comma q1, for example. Okay, then 2 power q will have all possible values of the state. So 2 power q is equal to, so phi is one subset, set of all subsets. So q0 is one subset, and q1 is one subset, and q0, q1 is one subset. That means a state and input can go to either no state or a single state, that may be any of the state, or it may go to all the states. So that is the criteria. So making use of this, yeah. Yes, Astuti, sir, I got an offer from IIT Bombay. I'm a PWD candidate and I have a certification of PWD. Okay, very good. And how is college check my PWD? By the medical team or only C certificates? So it will be, I think it's authorized certificate, Astuti. So authorized certificate only will be verified. Okay, fine. Now let us move. And a power m, b power n, c power k, m n k greater than or equal to 0. So this is nothing but 0 or more a's followed by 0 or more b's followed by 0 or more c's. Okay, so it is nothing but it is a star, b star, c star. A star, b star, c star is the regular expression. For this, you require to have NFA. NFA is very simple. So minimum string is epsilon. So that starting state would be a final state. Okay, we can have any number of A's without having B's also, only A's are acceptable. And if you go to the loop, 0 or more A's possible. Without going the loop, if you directly go with B's, and a single B acceptable, and any number of B's were also acceptable. Without A's, directly B's can be acceptable. And after B's, we can accept the C's also. Okay, so here also we can take a final state. And at the same time, only C's also can be recognized. So single C or any number of C's. Okay, directly after A's we can get C's, or B C's we can get, only C's we can get, A, B, C's we can get. So these are the things. So A star, B star, C star. So we are having three final states here. And there is no need of dead state because it is not a DFA. So it is very simple. Okay. And if you want only B's, this is also taken as a final. And there is no need of giving multiple transitions for a inputs here. Okay. Now coming to example 2, so I brought more examples here, and yes, and see, please subscribe the channel, and also please do share the class information with your friends. So W is a word of A's and B's, and there is a constant A, so that is nothing but any word of A's and B's is nothing but A plus B whole star, A plus B whole star followed by A. So 0 or more A's followed by A. So generally, if it is a DFA, it is difficult. So NFA is whenever there is a star, so we can have a self loop of A's and B's. So A slash B, and for A, we can go to the final state. It is a state Q1. So 0 or more A's or 0 or more B's, any number of A's and B's followed by A. So A plus B whole closure A. Okay, now I hope you people understood. Okay, now let's move on to the next example, example 3 and example 4. So W1A, W2, where W1, W2 combination of any A's and B's. It is nothing but regular expression for this would be W1 can be any combination of A's and B's. So it is A plus B whole star. And there is a constant A, then followed by W2 also can be any combination of A's and B's. And W1 and W2 need not necessarily be same, even though it is the same alphabet. For example, A plus B whole star, it is something BA. You may have AA also, but in between we can have A. It's very simple as it is NFA. So whenever star is there, we can simply give a self loop of A or B. And then minimum string accepted is A. So for minimum string A, we can go to the final state. Let it be Q1, and Q0 is the initial state. And after going to final state, any number of A's or B's also can be recognized. So this is how we can accept the things. I hope everybody understood this. Okay. So A plus B whole star, A plus B whole star. It is at least one A. We can say that all combination of A's and B's containing at least one A. Okay. Now? So now let us move on to the next example. So it is A, W, B, where W is a combination of A's and B's. That means it is starting with A and ending with B, in between any combination of A's and B's. So it is like this. A followed by A plus B whole closure gives you any combination of A's and B's followed by B. So string starting with A and ending with B. So what is the minimum string here? AB is the minimum string. So for AB we can go to the final state. For AB we can go to the final state. In between A and B we can get any combination of A's and B's. So this is the starting state. So any combination of A's and B's can be accepted. Okay. Hope you understood this. Is it clear? Okay. And for the first one, this is the regular expression. And the first second one, this is the regular expression. Okay, now let us move on to the next example 5 and 6. L is equal to W says that W contains exactly 2A's, where W is any combination of A's and B's. Exactly 2A's. Those 2A's may be anywhere, either contiguous or non-contiguous. Exactly 2A's means, for example, this is 1A and this is 1A. And before and after, any combination of B's we can have. Before this A, we can have any combination of B's. After this A, we can have any combination of B's. and after this also we can have any combination of these. So there are two A's exactly, and every A can be preceded by any number of B's, succeeded by any number of B's. So this is the regular expression. For this, we can have a machine like this: A, A, and before this A we can have any number of B's. After this A we can have any number of B's, and here also we can have any number of B's. That's it. B star A, B star A, B star. So this is the NFA for it. Okay, now? And sixth one, if you see, W says that W contains at least 2 A's. At least 2 A's, exactly 2 A's, there is a difference. At least 2 A's means we can have more than 2 A's also. So minimum presence of 2 A's is required. And before and after any combination of A's and B's. Here only B's. So any combination of A's and B's are also possible because it is at least 2 A's. A plus B whole star, A, again A plus B whole star, A, again A plus B whole star. So we are having at least 2 A's. So we can have NFA like this. Very simple. So minimum 2 A's, and before and after every A, any combination of A's and B's can be recognized. Here A or B, and here also A or B. So this is the starting state. So A plus B whole star A plus B whole star A plus B whole star. So this is the sixth one. Okay. And if you get any doubt, all of you can ask your doubts. Okay. Is it clear? Shall I go for the next? Example 7 and 8, let's see. Hope you are able to follow me. W says that W contains at most 2 A's. What do you mean by at most 2 A's? So maximum number of A's must be 2. So that means we may have 0 A's, we may have 1 A, okay, we may have 2 A's. Number of A's can be either 0 or 1 or 2. This is at a maximum. And what about B's? B's can be any number anywhere. If there are 0 A's, that means only B's are possible. That means B star. Or if there is only 1 A, for example, so this 1 A can be preceded by any number of B's or succeeded by any number of B's. Or 2 A's. So for example, if I fix 2 A's, and every A can be preceded and succeeded by any number of A's. Okay, so it is like this. So it is A, and before this B we can have before this A any number of B's, and before and after every A any number of B's are required. So it is a no A, 1 A, and then 2 A's. So now considering the NFA, only B's to accept, we can take starting state as a final, and we can give a self loop as a B. And B star A, B star to accept, so this also must be final, and we can take this B star, and one more final state you can take, and we can give a B star here. So only B's accepted, or B star A, B star accepted, or B star A, B star A, B star also accepted. So at a maximum 2 A's can be there. Hope you are following. Is it clear? So NFA construction is very easy if you try like this. And other example, XWX such that X belongs to A comma B. X is only A or B, but W is A or B whole star. That means it is a fixed. That means if X is replaced with A or B, and W can be replaced with A plus B whole star, and again X can be replaced with A or B. X can be either A or B. So that means we can take like this. It is something like A or B, A or B can't be accepted, but A or B can be accepted. And in between these A or B's, we can give A or B here. So that this gives you all the combinations. So this is the Q0, this is the Q1, and this is Q2. So A or B, A plus B whole star, A or B. Hope you understood. Shall I go for the next? Now coming to the question number 9 and 10. L is equal to W says that W is a string of A's and B's and modulus of W is equal to 3. So that means string length should be exactly 3. So string length exactly 3 means ARB, ARB, ARB. So it can be any string of length exactly 3. We may get a string like AAA, AAB, ABA, okay, ABB, okay, BAA, and BAB, BBA, and BBB. So these are the strings. So 3 times they are coming now. So you can take 3 times. It is NFA only. So ARB. You can go to final state only after length 3 is maintained, and that is stopped. There won't be fourth length and all. Is it clear? Now coming to the 10th one. W is a string of A's and B's where modulus of W less than or equal to 3. So that means string length either it is a 0 or it is 1 or it is 2 or it is 3. That's it. So maximum 3. Here exactly 3. So 0 should not be accepted. So maximum 3 means string length 0 can be accepted, means starting can be final, and string length 1 also can be accepted. That means next state also can be final with length 1 to accept. For length to accept, next state also should be final, and for length 3 should accept, and the next state also should be final. That's it. So these are the states. Hope you people understood this example 9th and 10th. And once again, I will show you all the examples. If you get any doubt on any example, please let me know once. So this is the first example, and the language is like this. And this is the second and third and fourth examples. Okay, these are the languages. And if you get any doubt on any example, you can just mention your doubt. I will explain. So for fifth and sixth, then it is seventh and eighth, then ninth and 10th. Okay, so ninth and 10th examples. You can see these finite automatas here, and let us see some more examples. L is equal to W says that W is a string of A's and B's. Modulus of W greater than or equal to 3. Greater than or equal to 3 means minimum string length is 3. That means A plus B whole cube, followed by after that any combination of A's and B's. So it is A plus B whole star. A plus B whole cube means you can write ARB thrice. ARB followed by ARB followed by ARB followed by ARB whole closure. Only closure is applicable for the last one. So we can take like this. So this is A or B. This is A or B. Then A or B. So length 3 minimum. So afterwards, any combination of A's and B's. Is it clear? Now, similarly, if we see the 12th one, W is a word and W start with either AA or BB. And W can be any string of A's and B's. So starting symbol can be either AA or BB. Then afterwards, any combination of A's and B's would be possible. So we can write A plus B whole star. Strings starting with AA, strings starting with BB. So how can we do this? So there are two things we can maintain here. So if we start with AA, for example, if we start with AA, then you should go to final state, and we have to go to any combination of A's and B's after AA. After AA, we can get any combination of A's and B's. Then if we start with BB, for example, then alternative path, for example, B here only, if you given AB or BA also will be accepted. That's why alternative path is provided. AA followed by A plus B whole star, or BB followed by A plus B whole star. This is the non-deterministic finite automata for the given language. Hope you people understood. And if you have any doubt, please ask me. I'm here to clarify your doubt. Okay, yes. Is my audio, video, everything is fine? People are not responding. I please respond somebody. You can just say hi or hello. Now let's move on to the next example. And W says that W end with either AA or BB. Okay, and W is any combination of A's and B's. That means any combination of A's and B's we can take, and after that ending can be either AA or BB. So ending symbol is AA or BB. So what should we do for it? How many states would be required here? What are the number of states required? So as per the regular expression, so we can take starting state, and for AA we can go to the final state, and also alternatively for BB also we can go to the final state, AA or BB. Hope everybody understood this. For AA or BB we can go to final state, but before that, this is a starting state. Any combination of A's and B's are possible. So A plus B whole star followed by AA or A plus B whole star followed by BB. So there are two possibilities. Is it clear? Hope everything is clear. And still, if you have any doubt, please ask me. And those who have not subscribed the channel, please do subscribe it, and also press the bell button for getting notifications, and also please do like the session. Okay, so in today's session, I just described what is NFA, and NFA is only theoretical aspect. Okay, our intention is to construct the DFA. In the next sessions, I will also explain about the DFAs, what to cover, and what is the coverage of syllabus within the DFA, and how to convert NFA to DFA. And the prime difference is NFA, we are having a non-deterministic approach. Multiple paths are possible for one string over any state, and for DFA there is a unique path. Okay, so that makes a difference. And construction of NFA, as we have seen today, it is very easy, but construction of DFA is directly, it is a little bit difficult. And but in the gate examination point of view, for every language what I have discussed today, not only these languages, for every regular language, whenever it is given, you should be get ready to construct the DFA immediately with minimum number of states. So if that type of practice if we can make, so that it will become a cakewalk for you for understanding the subject. Is it clear? And I hope every one of you have enjoyed the session today, and I wish every one of you all the best, and please do attend the sessions regularly, daily at 10:15 till the theory of computation, this crash course of summer is finished. Okay, thank you so much. Thank you one and all. Have a good night. See you all once again tomorrow. Bye bye.